Hello everyone, and welcome to today's chem lesson. Today we are going to be continuing our discussion on the atom, right? Moving forward from our last video talking about the history of the atom to the important parts that we use and need to know about for the things we're going to learn. We discussed last time that the shell model, where the nucleus is in the middle, and electrons orbit in rings, right, which are usually drawn as sort of semicircles, like this. Right. We've got a positively charged nucleus and electron rings where electrons live. Now, in the nucleus of every atom, we have protons and neutrons. And in all of the rings, our electrons. And today we're going to focus on these three things and what we know about protons, neutrons, and electrons, what we can learn by looking at different combinations of protons and neutrons, electrons, and protons. And basically just our general information about these subatomic particles. And we're going to start here with this handy little chart. All right, protons abbreviated with a lowercase p, neutrons abbreviated with a lowercase n, electrons abbreviated with a lowercase e with this little negative sign on it. They each have a mass, they each have a charge. Protons and neutrons have the same mass, and that is 1 AMU, or 1 U. AMU is a unit developed specifically to talk about protons, neutrons, and electrons, specifically used to talk about subatomic particles. Right? It translates to a very small amount of grams, right? Something like 1.8 times 10 to the negative 16th or to the negative 20th. And so instead of having that number, they being scientists made a unit specifically for subatomic particles, right? Atomic mass units. Neutrons have that same mass, and electrons actually have no mass. When we go and look at the charge of each of these things, protons have a positive charge. They are positive 1 charge. Neutrons are neutral. They have no charge. And electrons have a negative 1 charge. Right? This is why the nucleus is positive. Right? Because if we look at the two things that are in the nucleus, protons and neutrons, the only charge there is a positive charge. Our electron shells are negative, right? Because the negative electrons hang out here. And we can build on these ideas, right? We could build on the subatomic particles when we talk about our atoms and recognize things like the atomic number that we see, right? When you look at a cell on the periodic table, the atomic number is down here. That's equal to the number of protons. The mass in the upper corner is equal to the protons and neutrons together, which makes sense, right? Because they're the only pieces of the atom that have any mass, right? Electrons don't have any mass. And when we look at the charge and we try to figure out the charge of an atom, we're going to compare protons and electrons. Protons and electrons are going to start out the same, right? Giving every atom a default neutral charge, right? Equal number of positives and negatives. But the number of electrons can change. You can gain electrons or lose electrons to create a charge on an atom, right? Either positive or negative, depending on if you gained or lost electrons. We're going to leave the idea of charge for a later video, right? We're going to talk about ions, which are charged atoms, at a later date. Right, so for now, for today, everything we look at is going to have a neutral charge. Right, we're going to just leave it at the baseline, equal number of protons and electrons. Right, let's take a closer look at our periodic table and see how these things connect back. Right, if you pull up the reference table, right, the periodic table on your reference table, you'll see that there is a key given to you right in the middle of the periodic table. And it points out, here's your atomic mass, here's your symbol, here's your atomic number, your electron configuration, your oxidation states. Right, it tells you where everything is, so that if you look at any given cell on the periodic table, you can identify, oh, here's my atomic mass, here is my atomic number, here is my electron configuration. For today, like I said, we're going to be leaving electrons out of this discussion. Right? We're going to ignore electron configuration. We're going to ignore oxidation states just for now. But we will come back and address these things when we talk about ions. Every once in a while, you'll see a setup like this to talk about an element. Now, these numbers in these corners are going to correspond actually really nicely to the numbers that we see on their placements on the periodic table. For example, this number down here is the atomic number. Right, the same as it is over here. And that's equal to our number of protons. Then as we move to the upper left corner, we're given our mass number, right, which corresponds to this number up here, right, corresponding to our atomic mass. And this is the number of protons plus neutrons, right, because those are the only things in our atom that have any mass. And lastly, the number in the upper right corner here is our charge. Right, comparing our protons and electrons, it's actually protons minus electrons to get our charge. It's going to line up with our oxidation states over here, which again, we will be talking about at some point in the near future. But looking at this, we can relate any one of these symbols back to the periodic table using our key to figure out any information that we need to figure out. You'll notice that this is an element that is element X, but we can actually use our atomic number to identify which element this is. If we looked for element 20 on the periodic table, we would see that this should not be an X, this should actually be a Ca for calcium. Right? Calcium is an element with the atomic number 20, and it fits this combination, right? These things are linked together, right? Our atomic number connects back directly to our symbol. There's only one thing with 23 protons, and that's vanadium. Only one thing has 6 protons, and that is carbon. Only one thing has 20 protons, and that is calcium. And so we're going to take a look at a multiple choice practice problem and then some free response practice problems. Right? We're going to jump in with this first. Compared to the charge of a proton, the charge of an electron has what? Our answer here is actually choice 2. when we're comparing the charge of a proton to the charge of an electron, we know the charge of a proton is positive 1, charge of an electron is negative 1. These things have the opposite sign, so we can immediately cross out 3 and 1, which says that they have the same sign. So now we're stuck between choice 2 and 4, and really what we're stuck at is the idea of magnitude. Right? What does magnitude mean? Magnitude refers to the size of the charge. Right? It refers to the number 1 here. Right? These two things are the same magnitude. They are both 1s, but they have the opposite sign. Right? So if we were going to see some examples that fit in here, right? Greater electron with greater magnitude and the same sign would be positive 2 for electron and positive 1 for proton. Here for electron, negative 1, proton, positive 1. Right? Same magnitude, opposite sign. Same magnitude and the same sign would mean that electron and proton are both positive 1, or electron and proton are both negative 1. Greater magnitude and the opposite sign would mean that an electron would have a negative 2 and a proton would have a positive 1. Right? The only one that matches is choice 2. Right? Magnitude is going to refer to the number, while sign is going to refer to the sign. Right? It is really common to see questions that ask you to compare either the mass or the charge of these subatomic particles. And asking you to compare which one has more mass, a neutron or a proton. Asking you which one has more mass, a neutron or an electron. And any combination of asking you about charge or mass for any pair of those things is a common question, and that's where our little chart comes in handy. But I also wanted to look at some of these free response type questions. Using the information that we talked about, you should be able to fill in every missing number in each row. Right? I recommend that you work one row at a time, right? Fill in the first row, and then move downward to the second, then move downward to the third. And keep in mind those relationships that we talked about. The relationship between atomic symbol and atomic number. The relationship between atomic number and number of protons. The relationship between protons, neutrons, electrons, mass number. Atomic mass, I will tell you, is taken directly off the periodic table for each of these things. I'm going to give you about 3 minutes to work on this with some silence, like 3 minutes of dead air, and then we will go over some of these practice problems. I will show you these answers. if we go ahead and look at the answers to these questions, we will see some of those relationships that we talked about. Right? Atomic symbol is connected directly to the atomic number. Right? There is only one symbol that has 102 protons. 102 protons connects only back to this symbol. We will see that atomic number is directly equal to number of protons. We will see that protons and neutrons together add up to our mass number. Like we said before, we're focusing on neutral things, right? So since all of these have zero charge, we're looking at protons and electrons also being the same. And atomic mass comes directly off the periodic table. Now what I want to do is also give you the second set of practice problems that I have here, though I do not want to do them right now live. I'm going to put up this second set, and if you're coming back to rewatch the video, I would say pause here. I'm going to give about 20 seconds. Right? Pause the video, work as much as you want, and then check the answers, which I'm going to post soon. Three, two, one. Answers. Right. Giving you even more opportunities for practice problems if you're coming back to review. In our next video, we're going to talk about the difference between mass number and atomic mass and why these things are close but not always equal. Right? Sometimes they are, but look, 89, 88.9, right? Why are they similar but not the same? And that'll be our entire discussion for our next video. For now, I'm going to ask you to transition over to our Zoom meeting for questions, comments, concerns, and attendance, and I will see you there.